Hi, my name is John Holy cow. I'm John Mcphalen. I live here in the Valley, and this is going to be the easiest presentation because my other job is I'm an actor, so if I can do all this stuff, trust me, you can too. I thought we're all hackers, we all do programming, and I tend to use a propeller. Now, just for a little bit of history, my first microcontroller was a Cosmec ELF 1802 processor. Anybody use one of those? No old people in the room? Okay, an old guy in the back knows what I'm talking about. Yeah, in 1978 or 79. And it got me interested in microcontrollers, and ultimately then, the TRS-80 and the TS-1000 and a Commodore 64, etc. But I always wanted to control things. I had all the Forrest and MIM books that everybody has and was building lots of circuits and wanted to connect things together. So I ultimately was plugging things into the back of my Commodore 64 and controlling them, but that was decidedly inconvenient because it's quite big. In 1993, a little company up in Rockland, California called Parallax started advertising this cool thing called the Basic Stamp. And I saw it on the back of Nuts and Bolts magazine. I said, it's not true. There's no way you can make that work. As it happened, about 6 months later, I was scheduled for a surgery that was going to keep me out of work for a few weeks, and so I thought, what the heck, I'll spend $100, I'll get a Basic Stamp and see. Came home from work one day, was on the porch, opened it up. The next time I looked at my watch, it was 10:30 in the morning the next day. So I called my secretary and told her I was sick because you can't call in tired, it's not cool. And from then on, I've probably programmed Basic Stamps every day since. Now what happened ultimately, this was kind of pre the internet really taking off, so Parallax had a BBS, and every day I would log into their bulletin board system, download all the questions that people would post, and then solve problems. And that's a good way to learn anything, whether it's, the Propeller or the Arduino or any other microcontroller you're wanting to learn. Trust me, there are enough people in the world that want you to solve their problems that you have a lot of opportunity to learn new things by doing that. So you'll find me every day in the Parallax forums solving questions. To me, it's, I always say to people, if I could just motivate myself to go to the gym as much as I go to the Parallax forums, I'd be a lot thinner guy. So at any rate, the Basic Stamp 1 kind of took off. It was really, and for the younger people in the world, there was a really cool, easy to program microcontroller before the Arduino. Okay, I'm not knocking the Arduino. It's a cool little processor, but trust me, we were doing cool stuff with microcontrollers way before that cute little Italian job showed up. At any rate, I became very good friends with the people at Parallax, and ultimately when the Basic Stamp 2 was getting ready to come out, the guy that created the Basic Stamp 1, I should give you a little bit of history on this guy. His name, heart to God, his name is Chip, and he makes chips. And he goes by Chip because his name is Charles Gracie the second or third, and so anyway, he got the name Chip. He, like most of us, just started tinkering, and when he was 16 years old, he built a board that plugged into an Apple II that Apple paid him $200,000 for a design. And so he stopped going to school, high school, never went to college, just went right into chip design and started Parallax, which ultimately was one of the first companies to build programmers for microchip controllers. So he became very, very good with PIC. So if you go way back in Parallax history, bless you, they were one of the leading companies for PIC development tools. The Basic Stamp Chip developed because he had lots of friends like me who just didn't have the patience or the wherewithal to learn assembly. I don't like assembly very much. The Propeller, I'll show you, is actually quite easy in the assembly world, but the PIC stuff, never really enjoyed it. So the Basic Stamp was right up my alley. I could program in BASIC. I'd been doing that for a long time with the TRS-80 and Commodore 64 and all those other computers, and now I could control things. So it changed things for me. Subsequently, the Basic Stamp 2 came out. That really caused things to take off. And along the way, Parallax was asked by a company then called Xenix to help them with a chip called the SX. And the SX, for those of you that don't know what it was like a very fast PIC. And this actually led to some legal issues because it was too much like a PIC. The difference was, and this was really key to that processor, it interrupts architecture was the same no matter what happened. So you had no jitter in your interrupts, which we know is always a problem when we're dealing with processors that use an interrupt system. What that allowed the SX to do was create this system called virtual peripherals. You could create really high-speed UARTs. You could create lots of other things in the interrupt process because it had no latency issues, no jitter. It was very deterministic. Without going into the boring details, there were lots of legal entanglements between Microchip and Scenics, and that caused Chip to get really frustrated with lawyers in particular, and with the process in Silicon Valley specifically. So he said, that's it, I'm doing my own thing. And because he had been involved in that process, he decided to do his own chip. Well, interrupts, even if you make the architecture so that you don't have deterministic problems, it still interrupts your process. If you think about it, an interrupt is like going from here across the country. If you could do it on one tank of gas and no bathroom breaks, you'd get there really fast. But we know we have to stop for gas, we have to stop. Those are interrupting the flow of it. This slows things down. And when we get into programs that require specific timing, that can be problematic. So Chip made an architectural decision not to have interrupts in the Propeller processor. And just for the record, I'm not here to advocate against interrupts because I use processors that have them. I'm just wanting to show you, if you haven't explored the Propeller, it's much easier to get into than you might have thought about. I mean, when we were at DEF CON, so this is the badge from this year, not the batteries, this part. And the lights are an add-on that I did. So this is using the Propeller processor. I worked with Ryan and the team at Parallax to put this together. How am I trying to say? My experience coming from DEF CON was people had two basic comments. They said, wow, I didn't know the Propeller was capable of doing that. And the other one was, wow, I didn't know it was that easy to program. And I can tell you, like I said, my world is in art. I want to be a TV actor. I know it's ridiculous. I'm 52 years old and I'm overweight, but that's what I want to do. So I'm going for it. In the meantime, I make a living designing circuits and software. And now I'm lucky because I get to work in and around the entertainment business. So for example, I think someone said earlier, we were talking about the blinking lights. So I do that a lot. This is my latest blinky light project. So this is the face of a bear. Any gamers in the room? Probably one or two, right? So if you know the game League of Legends from Riot Games, this is the bear Tibbers. Now this is a close-up of his face, which is this big. And I'll show you another picture here. So here is the team of people that built it, and you'll recognize the fat guy in the middle. So you can see how big that is, and this is using one Propeller processor to animate all the lighting. I'll get into a little more details in a minute. But just, if I may, for my Hollywood friends, it takes a lot of people to put what you see on a screen. So stay and watch all the credits. Those people deserve it. Okay, one of those guys is in the front row. So it takes a lot of people to put what you see up. And this is the team that built that bear, from starting with 8,000 pounds of clay, lots of fiberglass, lots of foam, lots of paint and makeup, etc. And then my fun part is coming in and making 1,000 LEDs look like fire and flames and flashing, etc. But it's just blinking LEDs. So let me talk about the Propeller just a wee bit. The Propeller is, and just so we're setting the record straight, because the other day I was talking with a guy who works in the movie business, and in one moment he said, oh, I don't know, the Propeller is just too powerful. And I said no person ever. Nobody is thinking they have too much power. But in another sentence, a couple of minutes later, he said, oh yeah, it's an 8-bit processor. I said, no, it's not. It's 8 32-bit processors. So just to give you the layout of the Propeller, the processors are fairly simple. They really aren't very difficult at all. They're 32-bit processors, and they run, the system runs at 80 megahertz. gigahertz. It's 4 instructions, 4 clocks per instruction, so you're running about 20 MIPS per processor, and you've got 8 that are running simultaneously. All of the processors that you have enabled are running simultaneously. They are managed by a system called the hub, and that's what is taking care of sharing information between the two. So if you look at the Propeller as architecturally, here's the I don't know if we can, let me blow this down. So you can see inside the chip, you've got 8 processors that Parallax calls cogs. You notice that they're all tied to the IOs. Now, one of the first things that people get a little nervous about is, well, wait a minute, if one processor makes a pin an output in low, and another processor makes that same pin an output in high, am I not going to have an electrical issue? The answer is no, because you can see along the top, all of the outputs are ORed together. Now, the trick about this is if any processor makes an output high, that output will be high. Doesn't matter what the other guys are doing. And you can use this to your advantage. For example, if you're doing modulation of an IR signal, you can use another processor, which would be a waste. You don't have to, because there are counter modules inside the processor to create a modulation signal. And then you can write to the same pin, because it's ORed together, the control signal. So for example, the badges at DEF CON, they talk to each other. And we do that through IR stuff. It just takes one pin and one processor to handle sending any kind of IR modulation that we want to send. The other thing that you'll see, so the processors, you don't see UARTs, you don't see ADCs, there's no complicated kind of peripherals in the processors. There's 2 counters that are multi-mode, so you can use for PWM and waveform generation, etc. One of the interesting things, though, is there's a video generator built into every cog. So the Propeller out of the gate is capable of generating VGA graphics. Quinn, it's ready to roll, and in fact, a lot of people have used the Propeller as a VGA coprocessor for other projects, smart VGA coprocessor. So what goes on then is that the hub stores the image of your program, and you as an application person can launch it out to whatever cogs you want. The cool thing about this, and in some of the processes that I do, I create a simple process. For example, and I'll show you, well, here, I'll just go ahead and show it to you. There is another game piece that we did for Riot that is this guy. This is the finished piece. So this is a piece called Rise. So the ball of energy is kind of being split. But you might be able to see in the lighting, it's a little bad, they're little spiky images. There are a bunch of supports that are holding up that inner sphere to the outer sphere that we lit up with very high intensity LEDs. And Steve Wang, who is my boss on these projects, Steve is famous for creating The Predator and lots of other really cool movie monsters. He said, hey, can we make that look like lightning? And I said, you betcha, because I used to work in the golf course industry and I know what the timing element of lightning is. So I coded that into a little process, and he liked it. Then he said, wow, that's great. Can we have more? I didn't have to write any more code. All I did was take the lightning process and launch it into another processor. So I had 2 processors running the same code set, just with their own set of variables. And I'm going to show you how that works in just a minute. And instantly, we had a lot more lightning with almost no effort on my part. So you have the opportunity of creating simple processes where you want to duplicate. You can actually take that same set of code and run it in multiple processors. This is where, in fact, because the way that the timing and the cogs are connected together, the high resolution VGA object that's available on the Parallax site actually uses 2 processors to generate the VGA, and they're linked together. So what's going on is one of the processors does a scan line while the other is calculating the next, and they flop back and forth to generate scan lines with perfect sync. So you get nice VGA display without any real trouble at all. So that's one of those kind of out-of-the-box available processes. So we talk about the LED. So here's the inside. Now there's a really nice LED ball over that. Sometimes inside Hollywood props are not so pretty. So this is the inside of our ball, which was a WS2801 strip. Now when we did this, the WS2801s and 11s and 12s were just coming out. In fact, the 2801s were just available. So this was a very new thing. It wasn't as commonplace as it is now. Luckily, the two-wire version are very, very simple. And what I was able to do, and what I do with the lighting, same as on here, these are the WS2812s, is I devote a processor to updating these LEDs. So if those of you that have been around, show business or, the music industry, there's a protocol called DMX, which transmits lighting data to fixtures and gobos and those kind of things. It's just constantly being streamed out. And then the processor from the control, the show control, can just write into the appropriate memory locations of what it wants. It's just constantly being streamed. That's how I treat all of these LEDs. So I have a process that is running that is updating these LEDs 300 times a second. That way my animations can run at a reasonable speed and I never have to worry about waiting on anything or generating. So one processor is just sending data to the LEDs. The other processor is actually creating the animation. So in the Bear, for example, now that was using DMX. I have one DMX processor and I have 3 other processors that are creating the fire and flame effects. The animation processors know where in the hub, remember I was talking about this shared memory area, in the hub, all the processors have access to the memory that's here. And so that's how you communicate between cogs. If you want to send information from one processor to another, they only need to agree upon a memory location in the hub to exchange that data. So if you're creating a UART, for example, you would set up a buffer and then just publish, if you will, the address of that buffer. So as your UART code is receiving data, something that is using that buffer knows where to pick it up. So it's actually quite easy. And I'll show you, so we'll look at real code since we're all coders, right? Okay. One of the things too, this is, Parallax stumbled out of the gate. They're not a big marketing company. And, for the record, the Propeller and the Arduino came out the same year. Now it's interesting because a lot of people still haven't heard about the Propeller. Parallax is not a marketing company. They're tech people like us. They just want to do fun stuff. The Arduino has a cute Italian name. They're linked up with a very big publishing company, so they did well. But it's been around a while, and there's quite a lot of things happening to it, mostly quiet. Now I do my thing. I write for Nuts and Bolts magazine, so I've been putting out information. Most of the Propeller uses in professional applications that you wouldn't know about. I'm doing simple kind of lighting animation most of the time with it, but I have built camera control mechanisms for a company back east. I wrote an HVAC system for China that used Modbus to have remote input into the HVAC controller and used CAN bus for communications between nodes in the system. And that was on the Propeller using the Propeller's native language, which you see here. So when Chip was developing this, there were a lot of consternations internally because the Parallax brand had really been based on the BASIC stamp, and everybody knew BASIC and expected anything coming would be in BASIC. There were a lot of us that were kind of, now I'm not a big C programmer. Okay. I'm not much of a C programmer, but I recognize it is the dominant programming language in the world, so that was a discussion. But C was not intended initially for multi-core applications, and so Chip is kind of his own guy. He owns the football, so he gets to play quarterback, and he said, no, we're going to do our own thing. And he created a language called Spin. Now, it kind of goes into cute with the Propeller thing. But it's a very, very easy language. It's C-ish. There's some elements of BASIC in there. You'll notice some Pascal operators. And if you have any programming experience at all, I promise you can pick up Spin in a couple of hours. It's very, very simple. And I'll show you how it works and how we do multi-core applications with it. So here's some very simple things, defining constants, etc.
There's similarities to Python.
And well, yeah, the Python in particular, the indenting. One of the things, and this kind of aggravates C programmers. I say, suck it up. The indenting. It was interesting. I read an article recently by Guido van Rossum, and when he invented Python and that whole indenting thing happened. Social scientists had said people that program in other languages that use braces or begin and end markers, they indent properly anyway. So you might as well just get rid of the markers. The indenting is what we visually look to. So Spin uses that. Now I'm using the new open source tool which doesn't mark that. If you're on a Windows system, there is the Propeller tool will actually show you the indenting. But for example, I have skipped right past. Oh, there's a repeat loop up here. So you see it's indented underneath there. And so all loops, in fact, in Spin begin with that keyword repeat. And this one repeats forever. If you want to iterate a loop a specific number of times, you just put the number after repeat. That can be a variable. So if you said repeat X, whatever the value in X is when it hit that loop, it would repeat. Or you can say from to do a typical for next kind of loop. So it's always in that structure. So if you do decide you want to give the Propeller a try, I recommend this little board. It's called the Propeller Activity Board. It's a cute little board that has a propeller on it. It has power supplies. There's an XP socket. There's a micro SD socket. There's outputs for audio. There's a built-in ADC. So it's got nice little tools and a small breadboard. You can see I've got it populated presently with a couple of WS2812 NeoPixels.